Let's look ahead with automation. Let's look more into automation. Continuous integration, also known as CI, is a cornerstone of modern software development. In fact, it is a real game changer. When continuous integration is introduced into an organization, it radically alters the way teams think about the whole development process. So it has the potential to enable and trigger a series of increment process improvements, going from a simple scheduled automated build right through to continuous delivery into production. A good CI infrastructure can streamline the development process right through to deployment and help detect and fix bugs faster and provide a useful project dashboard for both developers and non-developers. So ultimately it help teams deliver more real business value to the end user. Every professional development team, no matter how small, should be practicing CI, continuous integration. So now let's look into some of the continuous integration fundamentals. Back in the days of waterfall projects and Gantt charts, before the introduction of CI practices, development team time and energy was regularly drained in the period leading up to a release by what was known as the integration phase. During this phase, the code changes made by individual developers or small teams were brought together piecemeal and forged into a working product. This was a hard work. This was like hard coding, sometimes involving the integration of months of conflicting changes. It was very hard to anticipate the types of issues that would crop up and even harder to fix them, as it could involve reworking code that had been written weeks or months before. The painful process, fraught with risk and danger, often lead to significant delivery delays, unplanned costs, and as a result, unhappy clients. Continuous integration was born. Then born this continuous integration. Continuous integration was born to address these issues. Continuous integration, in its simplest form, involves a tool that monitors your version control system for changes. Whenever a change is detected, the tool automatically compiles and tests your application. If something goes wrong, the tool immediately notifies the developers so that they can fix the issue immediately. But continuous integration can do much more than what I have just said. Continuous integration can help you keep tabs on the health of your code base, automatically monitoring code quality and code coverage metrics, and helping keep technical depth debt down and maintenance costs low. The publicly visible code quality metrics can also encourage developers to take pride in the quality of their code and strive to improve it. Combined with automated end-to-end acceptance tests, CI can also act as a communication tool, publishing a clear picture of the current state of the development efforts. And it can simplify and accelerates delivery by helping you automate the deployment process. So letting you deploy the latest version of your application either automatically or as one click process. In a sense, continuous integration is about reducing risk by providing faster feedback. First and foremost, it's designed to help identify and fix integration and regression issues faster, resulting resulting in smoother, quicker delivery and fewer bugs. By providing better visibility for better technical and non-technical team members on the state of the project. So continuous integration can open and facilitate communication channels between team members and encourage collaborative problem solving and process improvement, and by automating the deployment process. Continuous integration helps you get your software into the hands of the testers and the end users faster, more reliably, and with less effort. The idea of automated deployment is important. Indeed, if you take automating the deployment process to its logical conclusion, you could push every build that passes the necessary automated tests into production. So, the practice of automatically deploying every successful build directly and into production is generally known as continuous deployment. So, the practice of automatically deploying every successful build directly into production is generally known as continuous deployment. However, a pure continuous deployment approach is not always appropriate for everyone. For example, many users would not be appreciate new versions failing into their laps several times a week and prefer a more predictable and transparent release cycle. So commercial and marketing considerations might also play a role in when a new release should actually be deployed. So the notion of continuous delivery is a slight variation on the idea of continuous deployment that takes into account these considerations. With continuous delivery, any and every successful build that has passed all the relevant automated tests and quality gates can potentially be deployed into production via fully automated one click process and be in the hands of the end user with minutes. So within minutes. So however, the process is not automatic. It's the business rather than IT that decides the best time to deliver the latest changes. So, continuous integration techniques, and in a particular, continuous deployment and continuous delivery, are very much about providing value to the end user faster. How long does it take your team to get a small code change out to production? How much of this process involves problems that could have been found or fixed earlier? Had you known about the code changes that bogged down the corridor was making? And How much is taken up by a labor intensive manual testing by QA teams? How much involves manual deployment steps, the secrets of which are known only to a select few? CI is not a silver bullet by any means, but it can certainly help streamline many of these problems that I've just mentioned. But continuous integration is a mindset as much as a tool set. To get the most out of CI, a team needs to adopt a CI mentality. For example, your projects must have a reliable, repeatable, and automated build process involving no human intervention. Fixing broken builds should take an absolute priority and not be left to stagnate. The deployment process should be automated with no manual steps involved. And since the trust you place in your CI server depends to a great extent on the quality of your tests, the team needs to place a very strong emphasis on high quality tests and testing practices. So that basically, now let's look back into Jenkins, from where the Jenkins has come. Let's look into the history of his story of Jenkins. So Jenkins, originally called Hudson, is an open source continuous integration tool written in Java, boasting a dominant market share. Jenkins is used by a team of all sizes for projects in a wide variety of languages and technologies, including .NET, Ruby, Groovy, Grails, PHP, and more, as well as Java. So, what has made Jenkins such a success, such a huge, humongous success, and why we use Jenkins for our CI infrastructure? CI infrastructure. Firstly, Jenkins is easy to use. The user interface is simple, intuitive, and visually appealing. And Jenkins as a whole has a very low learning curve. As we will see in this part of fifth module, the third part of fifth module, you can get started with Jenkins in a matter of minutes. But still, I'm giving lot of explanation before we jump into the Jenkins, because I just want you to make sure the complete history of Jenkins, from where it has come and why do we require a Jenkins in the first place. All that information I would like you to know. So that's the reason I'm elaborating the introduction of Jenkins. So, however, Jenkins does not sacrifice power of extensibility. It's also extremely flexible and easy to adapt to your own purposes. Hundreds of open source plugins are available, with more coming out every week. So these plugins cover everything from version control systems, build tools, code quality metrics, build notifiers, integration with external systems, UI customization, games, and much more. And installing them is damn quick, easy. So, last but certainly not least, much of Jenkins' popularity comes from the size and vibrancy of community. The Jenkins community is a large, dynamic, reactive, and welcoming bunch, and passionate champions. active mailing lists, IRC channels, and a very vocal blog and Twitter account. So the development pace is fast, with releases coming out weekly with the latest new features, bug fixes, and plugin updates. However, Jenkins also caters to users who are not comfortable with upgrading on a weekly basis. For those who prefer less hectic release pace, there is a long term support LTS release line that lags behind the latest release in favor or more stability and a slower rate of change. New LTS release comes out every 3 months or so, with important bug fixes being backported. So this concept is similar to the Ubuntu LTS releases. They also release frequently, and so with Jenkins. Again, we will look into short history of Jenkins. Jenkins is the result of one visionary developer, Koshike Kawaguchi, who started the project as a hobby project under the name of Hudson in the late 2004 whilst working at Sun. As Hudson evolved over the years, it was adopted by more and more teams within Sun for their own projects. By early 2008, Sun recognized the quality and value of the tool and asked Koshoke to work on Hudson full time, so starting to provide professional services and support around Hudson. By 2010, Hudson had become the leading continuous integration solution with a market share of over 70%. So in 2009, Oracle purchased Sun. Towards the end of 2010, tensions arose between the Hudson developer community and Oracle, initially triggered by problems with the Java.NET infrastructure and aggravated by issues related to Oracle's claim to the Hudson trademark. These tensions also reflected strong underlying disagreements about the way the project was being managed by Oracle. Indeed, Oracle wanted to move towards a more strictly controlled development process with a slower release schedule, whereas most of the core Hudson developers led by Koshike preferred to continue with the open, flexible, and fast paced community focused model that had worked so well for Hudson in the past. So, in January 2011, the Hudson developer community decisively voted to rename the project to Jenkins. They subsequently migrated the original Hudson code base to a new GitHub Project 1 and continued their work there. So the vast majority of the core and plugin developers upped camp and followed Koshike Kawaguchi and other core contributors to the Jenkins camp, where the bulk of the development activity has been can be seen today. So after the fork, a majority of users also followed the Jenkins developer community and switched to Jenkins. At the time of writing, polls show that some 75% of Hudson users had switched to Jenkins, while 13% were still using Hudson, and another 12% were using both Hudson and Jenkins or in the process of migrating to Jenkins. Nevertheless, Oracle and Sonatype, the company behind Maven and Nexus, have continued to work on the Hudson code base, now also hosted on GitHub at you can see that if you go to the GitHub and type github.com/Hudson, you'll get their source code. So, but with a very different focus. Indeed, the Sonatype developers have concentrating on major underlying infrastructure changes around among other areas where Maven integration, the dependency injection framework, and the plugin architecture. So, this is the short history of our lovable, adorable, cute, beautiful Jenkins.